Hello, I'm Michael Schachter, Product Marketing Manager at Allot, and welcome to the Mobile Virtual Conference. Our next session is with Elia Havemann, the Product Manager of our DDoS Secure DDoS mitigation solution, and he will explain to us what is so unique about this solution. Take it away, Elia.
Thank you, Michael. I'm here to present to you our DDoS protection solution, which is called DDoS Secure, and a little bit about understanding the DDoS problem. So DDoS is a distributed denial of service, and that means you try to really get your target out of service instead of infiltrating it like in a regular hack. And those attacks can come from the outside. Obviously, the whole internet can attack your network or your services, but they can also come from your own users. So you also have to be prepared to protect against outbound attacks. Motivations for attacks: you want to make money as a hacker. Hacktivism is a big issue, like trying to get things off the internet that you don't like. Also interesting, smokescreen. That means that you attack a system with a DDoS so that the security personnel is, taken away by this attack, and so they won't recognize that you're actually doing something really dangerous in the back end. You have revenge attacks, people that play online games and got shot, so they do revenge DDoS. And cyber warfare that's coming from countries attacking other countries. And they happen all the time. This is a map, a real-time map that you can get from the internet of attacks going from everywhere to everywhere on this planet. So DDoS is a real thing, and it happens all the time. Let's look a little bit at the trends. If you can look at those numbers, then you see that most of the attacks, like 72% of them, are actually volumetric. And that is interesting because the volumetric attacks are those that actually harm CSPs on the way to the target. If you do a DDoS, you want to kill the target, but you can also kill everything on the way to the target. And that is where volumetric DDoSes are the biggest problem. And we see the number of attacks increasing. We see them becoming shorter, meaning you have more hit-and-run attacks. And the complexity is increasing, and that is due to IoT botnets that allow attackers to really craft attacks to the specific target and not just do some random attacks like they used to do in the past. Biggest attacks we've seen: the biggest attack ever was close to 2 terabits. It was an unnamed US provider, and it was a reflection amplification attack based on memcached. And that happened in 2018. And you might wonder, now it's 2020, why didn't we see anything bigger since then? And that is because this attack vector actually has been fixed. It was using open memcached servers, and they have an amplification factor of 50,000. So meaning for 1 gigabit of traffic sending out, you get 50 gigabits of traffic back, 50,000. So these servers have been closed, and so the huge attacks are mainly a thing of the past, but the amount of attacks just increased. DDoS, as I said, is not only a problem for the target that is getting attacked, it's also a problem for the service providers on the way. So a DDoS can have, you can look up the numbers in the slide, you can have up to 25% of a complete country's total traffic. And 25% of traffic, that's a lot. That's real money and that's real cost. So DDoS is something that really is not only annoying, it's also something that's actually costly. And when we come to costs, each event can cost about $100,000 per event, depending on the size of the network and the size of the attack. Some even see attacks that cost them $1 million per event, and the prices are combined out of personnel that have to mitigate the attack, marketing, loss of brand reputation, and so on. But the average damages that we saw is about $20,000 to $40,000 per hour of attack. And so you miss your SLAs, your call centers are under stress, your infrastructure needs to recover from those attacks, and you have churn and promotion losses. because of this trend that we see more small attacks, the traditional scrubbing centers that you see in a lot of networks are kind of not ready for the task anymore, because the diversion to the scrubbing center takes time, and by the time that happens, the attack might be over already. And with an attack that is over the minute you start defending against it, then you can just not defend from the first place. And until you get to the scrubbing center, you have quality of experience degradation. The service becomes slower and sluggy, and people will complain. And this is actually something that we see in one of our customers. It's a little bit older, but you see that even in 2016, this trend already started, that you have a lot of very short-lived attacks, like all of them, most of them below 10 minutes. You have one that is 25 minutes, one that is 60 minutes, but other than this, most of them are really, really short attacks. Yeah. So, what do we do about this? First of all, there's 4 pillars that you need, 5 actually, pillars that you need in order to build a very good DDoS solution. First of all, it has to protect the whole network from all sides. Like we said in the beginning, attacks come from the outside to the inside, but sometimes they also come from the inside to the outside. And that can harm your own infrastructure, but it can also just be bad for your own network reputation. Quality of experience, that's something that you live off. Your clients have to be happy and love your service. So the minute quality of experience is suffering, you're suffering as a company. You have to be fast. If you're not fast, then the hit and run attacks will be something that you are just completely vulnerable to. And even though we see that the sizes were shrinking of the biggest attacks, actually most of them are now below the 200 gigabit mark. Still, you have to be able to mitigate also big attacks. And because of the new complexity, you have to be ready for all kinds of new attacks. You can't wait for some kind of researchers to understand what kind of attacks we have, and then a week later be able to defend against them, because then it's just too late. You have to be ready for 0 day. So, what do? We sit in line. That means we see all the traffic, we see every single bit that goes through the wire. We're not depending on some kind of statistical information we get from routers. And when we sit in the line, we can see the smallest attacks, the biggest attacks, and we see the actual traffic going through. So what we do is, when we see an attack, we actually take a PCAP, meaning we capture traffic, analyze the traffic, and with machine learning algorithms create a signature for the traffic that we see in this moment in this network, okay? And everything is completely automatic, no supervision necessary. After everything's set up correctly, it will work like in a closed loop. How does it work? We need to have a centralized controller. In big networks, you have always asymmetric traffic, meaning you have traffic coming in through one POP and leaving through another. In order to be able to deal with those situations, you need to have some centralized element that sees all the traffic. And this is how we do it. We have a centralized controller speaking to all the different inline devices we have in the network, creating its statistical models, and based on this will then detect and mitigate attacks. And this is how it works. First, we learn the traffic. Then we detect attacks through statistical methods. Then we analyze the attack, like I said, with downloading some part of the traffic as a PCAP. Then we create a pattern, and then we activate a policy that will send the pattern back to the inline devices that will then mitigate the traffic wherever they are. This is some insight into how we actually work, how our statistical models work, because one thing that you do want to avoid at any cost is over-mitigation. Let's say one of your clients just offers a new service and markets it worldwide, a new website coming up and coming alive, and you're going to have a spark in traffic. It looks like a DDoS. It's like so many people coming and wanting to see this new offering at the same time. It really looks like a DDoS. And we have a way to prevent this being seen as a DDoS by comparing every attack signal that we see to a secondary signal in order to make sure that the secondary signal is not affected. If the secondary signal is also affected, we know it's a regular spark. If it's not affected, then we understand this is a DDoS. This just on a high level, okay? Another thing, quality of experience. We talked about it before. People have to be happy, and every detection and mitigation takes time. Even if you are the fastest in the market, it always takes time. So it makes sense that before the attack is even detected, you have something in your network that will assure quality of experience. And we're doing this with our DPI, meaning that we can say, we have UDP traffic. Most attacks big attacks are UDP. And some of the UDP applications are really crucial to your network. That is, for example, DNS. Without DNS resolution, people believe they're offline, okay? Because nothing works. So we can prioritize this kind of traffic no matter whether we detected the attack or not. And when we did detect the attack, then we start removing it, but beforehand we have a congestion management. We spoke about over-mitigation. Over-mitigation means that you block stuff that you shouldn't have blocked. And one of the things we do, and this is a strength of our platform, is that we are session aware, meaning that we understand for every packet, no matter where it goes through in the network, to which session it belongs. That means if you attack, for example, a NAT gateway because you want to attack one of those users, then only the attack traffic to that user will be actually mitigated. Because we understand that all the other users initiated the connections and the answers are legit. The preemptive rate limiting. You have two scenarios in this graph. The top one is a regular DDoS solution from another vendor. The bottom one is ours. And we are in the moment of quiet time. You have the DDoS solution in the middle, the internet to the right, and then you have a firewall that belongs to the operator. The firewall has a capacity of 10 gigs. Before the attack starts, everything's fine. Then we see a 20 gigabits of UDP fragmented attack. The 20 gigabits are not detected yet and not mitigated yet because it takes time. And that will kill the firewall. A killed firewall needs to reboot, needs to come back to life, and this is going to create a real outage afterwards. When we see the 20 gigabits, we do 9.99 gigabits quality of service rule that will then prioritize critical services like DNS or BGP. And the firewall will be fine. After the mitigation starts, we're all happy. But before the mitigation starts, we need to do something in order to protect our network. What are our advantages? First of all, we can do more than 500 gigabits inline per device. We're actually planning a new device that will do more than a terabit inline. It's completely unsupervised, closed loop, fully automatic. Remember what I said about the smoke screen?
Yeah.
It's trying to cover up your attacks, your real hacks by a DDoS. If you have an unsupervised solution for the DDoS, this is not an issue anymore, okay? QoS assurance, we just talked about it in length. Real-time mitigation, from 15 seconds we can start mitigating. Some attacks take longer, some shorter. We're always below a minute, always, no matter what. But we can start from 15 seconds. We do incoming and outgoing DDoS in the same quality. Other solution, sometimes for outgoing DDoS, when they offer it, if they offer it, they just offer some fixed thresholds. And zero-day protection. We actually treat every attack like a zero-day. We do not rely on some threat database, okay? And we have the preemptive rate limit that you just saw before. Let's talk about a different subject. DDoS is also originated by hosts that have been abused. And in order to maintain your own network credibility, for example, you want to understand which ones of your hosts are actually part of a botnet. Maybe the traffic itself doesn't really harm you, but it actually does affect your network's, how you call it?
The reputation. With
Reputation,
the
yeah, exactly. The reputation. You know, you and hosts will get into blacklists, and you will have to maintain a team that will remove them from blacklists again. And this is cost, and this is reputation. So we have a feature in our DDoS solution that actually can monitor millions of subscribers and pinpoint those that do something weird. So you can quarantine them, help them to fix their systems, and make sure they're not becoming part of any kind of botnet. And we see these 5 different attacks. We actually added some more for IPv6 because there's new attack vectors coming up with IPv6. And basically seeing something that a normal user would never do. Okay? You can look at the screen in order to understand. A normal user would never do a port scan. That's something that a hacker would do, or a tool that tries to infect other devices. That's what we have today, but you know, we're always moving forward. And so I want to talk a little bit about what's coming up this year, and some things we're actually pretty proud of. The first one is slowly evolving floods. We've seen that people start changing and morphing the attack patterns in a speed that would make it hard for any kind of DDoS solution to adopt as quickly. And we found a new model in order to be able to constantly monitor mitigation quality and change our patterns while it's happening. Another one is critical services protection. We spoke about it before. DNS traffic is crucial to a network. You can't interrupt it ever. And we have new techniques in order to be even more precise in that and actually try to map rules that will make sure that critical services will never ever be filtered. In HBUT, what we just saw, the host-based anomaly detection, we created new attack types for IPv6. Did you know that in an IPv6 network, one subscriber gets more IP addresses to his own use than the whole IPv4 internet? Okay, that can kill any address table of any device. You want to be protected against an abusive host. FlowSpec. FlowSpec is something that's very exciting coming up. We see it more and more in networks. It's an addition to BGP that will allow you to not just black hole traffic, something that we support today, like every other DDoS solution, but will also allow you to send mitigation patterns via BGP. We improved the high availability. We created geo-redundancy, which is very important for our Tier 1 customers. We enhanced the UI and will continue enhancing the UI, and also give a CLI that works in Tier 1 environments and has multi-users. So, people love our solution. The customer feedback we get from customers that installed our solution is phenomenal. I don't want to go through all of them. Just a little map to see where we deployed, and it's really worldwide. We have to work on South America, to be honest. Okay? And just come with one customer testimony. And our customers are just happy. And they're happy about the fact that they don't have to really think about DDoS anymore. That's a thing of the past. They sit it there, it sits there, it works, and they can forget about it. And that's how it should be.
Thank you, Elia. It sounds like a great solution. Just a couple of questions to sort of crystallize. It seemed like the inline concept is one of our differentiators, and if you could just sort of summarize the advantages that the inline gives us over the other kinds of solutions like the scrubbing, like the FlowSpec, and so on.
Yeah. So we sit inline, and we have to sit inline in order to do the magic that we want to do. There are other solutions that support net flow statistics coming from routers. And this is, for huge networks, a great solution because you don't have to go and deploy everywhere. And if you have such a network, then we will be there for you in the future and not today, because we actually have to be in line. But only when we're in line, we can see everything, we can do the zero-day protection, and we can see the smallest attacks and mitigate the fastest. When it comes to 5G coming up, then the networks start to become virtualized. And then we can be a virtual function because we are fully NFV compliant. We can be a virtual function everywhere in every POP, and this is not a limitation anymore.
And the fact that you didn't talk about layer 7 DDoS, why don't we address that, or do we address that?
Yeah, layer 7 DDoS is basically a web application firewall function. There is a very interesting attack in layer 7, for example, when you have an SSL connection to a web server. The SSL protocol allows the client to renegotiate the key whenever they want. And the renegotiation process is much less CPU intensive on the client than it is on the server. And that's DDoS, using less capacity on the attacker side to create huge impact on the target side. So the layer 7 attack is that thousands of clients that have regular traffic renegotiate SSL all the time until the CPU dies on the server. We don't decrypt SSL. We sit in the network, we sit inline in the network, and we're agnostic to what happens on the server side. In order to protect against those kind of attacks, you need a tailored solution for that web service, for that backend. And you need to put a WAF there. But isn't it great to know that when you have a WAF, that it will actually be able to do its work because it's protected by us from the volumetric ones?
Okay, so the combination will give you the comprehensive solution.
Exactly. Find the right thing, the right solution for the right problem. And for volumetric DDoS, Allot is the right solution.
Thank you, Aliyah, and thank you all for joining us. If you would like to get in touch with one of our experts, somebody from sales or our executives, please use the form that will appear shortly on the screen, and please feel welcome to tour about the virtual demo space. You can see other demos, you can see the demo tour, view webinars, and hear our executives and other experts. Thank you again, and thank you for a very exciting and interesting DDoS presentation.